So this idea of a function is really, really important and really, really central. Now, I want you to kind of get that in your head. The reason why I started there is because functions are kind of core idea, a central idea, in mathematics, okay? It's literally just rules and just seeing how things change as you sort of fiddle around with inputs and seeing how the outputs change. Now, I touched on an idea when I was talking through that about this, okay? The rate of change, the rate of change. In fact, let me bring up my original graph. Okay, so my original mapping, this thing here, okay? I touched on this idea of the rate of change. Now, I said, as you move the input value close to 0, can you see that my output grows really, really quickly? Can you all see that? Okay, so my output grows really, really quickly. But then as I move it further and further away, my output tends to slow down. Okay? So what I'm literally talking about here with rate of change is I'm talking about the speed of growth. Okay? I'm talking about speed. How quickly is my thing changing? How quickly is my thing changing? Right? Now this is a central idea in mathematics, asking the question, how quickly is something changing? And it's called differentiation. So, differentiation. This is going to be our topic for the next kind of couple of weeks. Just by show of hands, who in here has looked at differentiation before? Some people. Okay, some people. So we're going to get quite in depth with this. So I really want to kind of get that fundamental understanding there. That fundamental understanding there. Okay. Odell?
Yeah.
Excellent. Now, have a think. Have a think. Rate of change. Well, let me just write a function up on the board. Let's suppose I have something like y equals 3x plus 4. Y equals 3x plus 4. Okay? Now, just to put it in context, let's imagine that y represents the amount of money I have. Okay? So I put some money in a bank account, and y represents the amount of money I have, and x represents any particular point in time. Okay? So y is money, x is time. Would you be happy then that this is a function? Okay, because it links together your input, in this case your time, with your output, in this case your amount of money. So it's still a function. But it's a function which says the question, you tell me how long your money has been in your bank account for, and I will tell you how much money you will have. Does that make sense? So let me say that again. This function actually asks the question, you tell me how long your money has been in your bank account, so you give me time, and I will tell you how much money you will have.
It's like an interest.
Exactly, exactly. Yeah, so it's kind of like an interest rate question, right? Now let's think about this. Let's not focus on this so much. Let's focus on the idea of rate of change. In this case, what would the rate of change be? So how quickly is my money changing every single time period?
Maybe the value left to x3, for example. So
Right.
it says x go like this, but this time it goes 3 times.
Good. Absolutely right. Absolutely right. Yeah. So let's just to illustrate this. How much will I have in my bank account at the start, at time 0? 4. Right. How much money will I have in the bank account, say, a month later? 7. How much money will I have in the bank account another month later? Another month? 13. Yeah. You happy with that? Okay. So every single month, my money is growing by £3. Okay, so every single month my money is growing by £3. Okay, and if I was going to draw this, okay, you happy it's just a straight line. So I get something that looks like this. Okay, that point there would be 4. Okay, so every single time I go across by 1 month, okay, would you be happy that I go up by £3? Okay, what concept am I describing here? So I'm asking about the rate of change, how quickly something is changing. What concept am I describing here? Simpler than that. the gradient. Yeah? Another word for gradient, by the way, is slope. Another word for gradient is slope. Okay? So when I'm saying the question, every single time I move along by 1 month, so every month, how much am I changing by? What's my rate of change? It's literally my gradient. Okay? Can anybody remember how to work out the gradient of a straight line? How to work out the gradient of a straight line?
With Greek sounds.
So the gradient of a straight line is simply rise over run. Okay? Rise over run. Or another way I can think about this is it's how much I change in the y direction by how much my money changes divided by my change in time, divided by my change in x. Okay? So delta y, change in y, over delta x, change in x. Change in y over change in x. Okay. Now, are you happy that in this case, just a straight line? So my rate of change actually is constant. It's £3 every month. Okay? But I could have equally had a different situation, something like this. Okay, x squared plus 4. Now, are you happy now that my rate of change is no longer constant? Let me illustrate. Okay, so at time zero, how much money will I have in my bank account? £4. A month later, how much money will I have in my bank account? And then a month later, how much money will I have in a bank account? And then a month later?
13.
Yeah? So now I'm no longer changing by the same amount. Like, have a look. I go up by 1. So the first month I increased by £1. Not very exciting. But then between months 1 and 2, I changed by £3. And then between months 2 and 3, I changed by £4. So it's no longer going up by a constant amount. In other words, the rate of change is now different depending at which point you're looking at. Yeah? And in fact, you can illustrate that through the graph. If I illustrate that through the graph, I would get something that looks like this. That's 4. At any particular point, my rate of change, so for example, that point there, the rate of change will be different at, say, another point in time. For example, over there. Do you see that? Yeah? So the rate of change at that point in time there will be different to the rate of change at that point in time there. So what now am I describing? I'm still describing gradient, but the gradient of what? Yeah, what do I call that line? It begins with a T. Tangent. Right. Gradient of my tangent. Okay? So if I have a situation that is non-linear, okay? Non-linear. In other words, I don't go up by the same amount for every single time period. It's not constant rate of change. Okay? So it's non-linear. Therefore, because the rate of change is different depending on which point I'm looking at, I have to look at the gradient of the tangent. So I need a more elegant way of describing rate of change. Because I still haven't answered the question, like, what is my rate of change? I know it's different at different points, but I want a more concrete way of actually working out how much it's changing by. Okay? So therefore, I need to look at this idea of differentiation. Does that make sense?
Yes.
That makes sense. Okay.
So in differentiation, some that we are changing, looking for change in y and change in x, but how, like?
That's exactly my question. Okay? So you can see now, in fact, let me play on this idea.
I mean, I didn't get it in for 3x plus 4 example too, so I got confused, like, for example, what's the difference in y here and what is difference in x?
So if you ask me about the difference in y and difference in x
Yeah.
in this case, okay, so I know then, for example, at time 1, I end up with 7, so that's my first point,
Yeah.
1, 7. And then my second point over here would be 2, 10, right?
Mm-hmm.
So therefore I can work out my gradient just simply by thinking about the change in y and change in x. So my change in y from there to there is going to be 3, and the change in x in there and there to there is 1.
Mm-hmm.
So therefore I take my change in y, which is 3, and I divide it by my change in x, which is, in this case, 1, and I'd end up with 3.
Okay.
Okay, so just by definition, in fact, you can think about this in a little bit more detail, but just for the time being, think about gradient as it's saying, what's your change in y for every change in x that you're doing? Okay, so it's literally changing the y direction for every unit that you change in the x direction.
Okay.